Hello, fellow Econauts, and welcome back to our show. I'm here with my brother Ben, the Rocketman, and we wish you a happy new year. Hey, Ben, how are you?
Hey Simon, how's it going? Happy New Year, fellow Econauts, and welcome to season 2.
Season 2. It's unbelievable that we are already in season 2. We just jump right into it with
Yeah,
our topic today, which is space history Saturn V over there. Exactly, that's the Saturn V. And maybe we can start by looking a little bit into who actually has been behind the Saturn V.
of course. I need to grab into the box a little bit of history here. I mean, it is space history after all. I will keep it brief though, so I don't want to go into much detail. So after the Second World War, a new conflict arose, which was the Cold War, Soviet Union versus the United States of America, and the space race emerged. So America, they got Richard von Braun and a huge number of engineers to America, and they got to a program to develop a, a way to get into space. And for that reason, they worked on the design of the Saturn rockets. The first Saturn rocket to deliver a person into orbit was the Saturn 1 and the Saturn 1B. And then subsequently, because the space race moved on, and as we all know, with the Apollo mission, the space race was actually to reach the moon. Richard von Braun was tasked to design Saturn V, or a Saturn rocket, to bring people beyond Earth orbit to the moon.
Saturn V was actually designed to bring a spacecraft into space and to the moon as well.
Yes, correct. So specifically to the moon, even more so specifically designed to be the vehicle for the Apollo mission. Apollo 8 was, I think, the first one where people circumvented the moon. And as we all know, and we had that episode already, Apollo 11 was then to land a person on the moon. And there were a number of other Apollo missions afterwards. Richard von Braun, though, designed the Saturn rocket to reach other planets, though, so specifically Mars, but it was never really put into a program.
How does the Saturn V actually work?
The Saturn V, and whoever has that model of Lego can actually try it out, is a 3-stage heavy lift rocket, which means, similar to the SLS, which we already discussed, there's a little spacecraft on top, and there's 3 stages embedded in the rocket itself. The first stage will lift the entire rocket until the fuel is burned, will then split off and fall back on Earth, splash into the ocean. The second stage will launch and bring the whole contraption even further, will then also fall away and fall back on Earth and into the ocean. And then the third one will push further until the spacecraft is then released and goes wherever it has to go.
So the Saturn V, different to the SLS, has no booster rockets on the sides?
Yes, the reason for that is, so the Apollo mission with Apollo 17 was abruptly stopped in favor for the space shuttle mission. And because NASA had still so many space parts or parts left over from the shuttle missions, from the booster rockets and so on, they actually reused all those parts for the SLS because they had them already in the shelf, more or less, on the shelf. So they reused that, and in favor for those parts, they designed SLS.
So if I understand that correctly, and I'm obviously not the rocket scientist here, that's why I'm asking that question. Is the SLS rocket shorter than the Saturn V?
Well, the comparison is a bit clunky because they come both from a different design perspective. However, the SLS is a bit shorter. I think Saturn V was about 110 meter, whereas SLS is 100 meter.
Okay, so it's not very significant, but it's still
No.
a design difference, which is the reason why the SLS is going with the booster rockets on the side, and the Saturn V had no booster rockets, correct?
Yeah, again, it's a different design. So the Saturn V was a stacked a design where the rockets more or less are stacked on top of each other, whereas the SLS, just as a reminder, SLS is the rocket for the Artemis mission, just to make sure everybody's on the same page. The SLS rocket is working similar to the shuttle launch, where we had also the extra boosters on side of the main rocket.
Right. But that
Yeah.
I just wanted to paint a picture for myself. So the design, and correct me if I'm wrong. So the design for the Saturn V, it's basically the three stages that you mentioned, and in comparison, the SLS has the three stages by having the boosters. Let's put it in layman's terms, replaced one of the stages.
Yeah, so the other difference is that the boosters are solid fuel, which means that the rockets burn from the inside out pretty much, and the remaining stages are liquid hydrogen and liquid oxygen, whereas the Saturn V was completely fueled with liquid oxygen and liquid hydrogen.
And that's the reason why the Saturn V has three stages, and the SLS, it's using the booster rockets as one of the stages.
Yes, correct. Yeah.
Okay. Well, but both of them are ending up on the moon at some point.
Yeah, not the rockets itself. I think
Not
that's
the
also,
rocket itself,
yeah.
I think,
The spacecraft, the spacecraft just here on the tip, so it's in a fairing similar to the SLS setup. That fairing will fall apart and then reveals the spacecraft. Obviously, in SLS is the Orion, and then that spacecraft is being pushed into a trajectory meeting the lunar orbit.
Right. That's exactly what I meant. I mean, both rockets are basically bringing the payload. We saw that in the comparison when we looked at the SLS rocket. The payload will be shoot into space. That's basically both designs are capable of doing that. And regardless what the payload is, either it's a spacecraft or could be a satellite or could be a part for the station, right? For the ISS or later on for Gateway.
Yeah. Well, I mean, the Saturn V and SLS would be a bit oversized to just bring a small satellite up there.
Sure,
but you're right. You're right. In principle,
for as the principle, it is basically designed to just bring, and I think that's what is so amazing to wrap your head around. And I'm always saying that it's such a big rocket necessary to bring a teeny tiny module into space. So much power is necessary to actually escape the gravity and to actually get into space. And as soon as you're in space, it's like I just play it down a little bit, but it's easy peasy basically.
Yeah. Well, the interesting part is that as long as you're in orbit of Earth, you don't really escape gravity because you're using the gravity
right.
You're continuously
falling. Yeah, you're continuously
exactly.
falling. Yeah, that's the orbit. Yeah,
but you need to reach a certain height or certain velocity, obviously. So maybe that's something which is interesting. A rocket starts vertically, right? But the reason for that is only to gain some height because first of all, the lower on Earth, there's obstacles in the way, like buildings and stuff. But also the density of the air is a bit thicker. And the higher you get, the lower the density is. And then at some point, they actually tilt into a horizontal motion.
They start falling.
Exactly. And then they start to accelerate towards the horizon. And if the acceleration is large enough, they start falling. If that acceleration is just enough to fall a little bit over the horizon, then we're in low Earth orbit. And when we're very fast, then we fall further and further away until we might even reach geostationary orbit. But we need a lot of energy to actually get that velocity. And then we have to maintain that velocity at that point, which is obviously easier the further away in space we are because we have no friction anymore from any air. And then we continuously fall around the Earth. Geostationary, just as a side note, is just that is special because that falling speed in geostationary orbit means we fall at the same speed as the Earth rotation, which is why it's called geostationary, because when things are in geostationary orbit, from our perspective, they stay at the same place in the sky.
I think it's also interesting to think about the following. In the beginning, the rocket is of course a lot heavier and has to launch into space, and then with each stage that the rocket is actually getting lighter because they're like less parts, right? Because they're yeah, well, they're basically uh, um, yeah, broken away from the rocket, right? That's I think it's very important to know regardless if they are booster rockets that get split from the main rocket,
Yeah.
or if you have like the stages like the Saturn.
Well, also, most of it is just a filled container with liquid hydrogen and liquid oxygen. So it's pretty much just a vessel for fuel with a little rocket nozzle at the bottom, and some fairings on the side, so to keep, you know, bit of trajectory and stability. But yeah, otherwise, you know, it's we just shoot a lot of fuel up there. Like 89%, 90% of the whole rocket is just the fuel in terms of the mass.
That's already it for today. I hope that you had a good first episode of 2024, season 2 of the Econauts.
Season 2.
Season 2 of the Econauts.
Mm.
We have a lot of fun making those episodes for you, and we again wish you a happy new year and hope we will see you in the next one. If you haven't already, please subscribe to our channel. Like if you like this episode.
And hit that notification bell.
And hit that notification bell. Exactly. Have a good one. Bye-bye.
Bye.